This is Ms. Miner, and this is assignment 9D. And today our goal is to be able to find the side length of right triangles. And this is related to solving equations with radicals. And so we're going to find out how this is related to what we've been doing in this unit. And we're going to start off, though, by just reminding ourselves a little bit of things about some right triangles. So we're going to do some vocabulary here, just a little bit. Okay. So starting out, what is a right triangle? Well, a right triangle is a triangle that has one 90-degree angle in it. And we usually signify a right angle by putting a little box in the corner. So if you'll notice this angle here is the 90-degree angle, and it has a little box in the corner. And so the symbol that we use for a right angle is that little box in the corner. That says this is a 90-degree angle. Okay. A right triangle has one 90-degree angle. It's a triangle where one of the angles is 90 degrees. Any other angle, the symbol that we use for any other angle is like just a little angle. Sometimes we put an arc in there to show that angle, but the symbol that we use for any other angle besides a right triangle just looks kind of like that, like an alligator mouth almost. Okay. The symbol that we use for a triangle, a lot of times what we will do is we will label the points. So we'll say, okay, this is A, this is B, this is C, and then we will say, this is triangle A, B, C. Like that. And so we identify a triangle with an actual little tiny triangle symbol. So you'll see oftentimes triangles labeled like that. Okay, the last symbol that we need to remember is the square root. And remember, the square root is the opposite of the exponent squared. And so the square root symbol is that check mark right there, and we're going to use both of those. The square root is the opposite of like x squared, the exponent of 2, and these two things, the root and the exponent of 2, they cancel each other out, and we're going to need to remember that. That's something that we've been talking about in this unit. We're going to need to remember that as we start kind of working with right triangles today. Okay, the other kind of vocabulary that we need to know are, what are the legs? And the legs are the two short sides of a triangle, of a right triangle. So the short sides, this would be a leg on this side, and this would be a leg on this side. The hypotenuse is the one long diagonal side. It is the longest side of a right triangle. And so the hypotenuse is this side. So if this is triangle A, B, C, we usually use the letter C to denote the hypotenuse side. So the letter C would be the hypotenuse side, and the letters A and B are used to denote the legs. And A and B are kind of interchangeable. It doesn't matter which leg I label A, which leg I label B. I'm having so much trouble saying this. It doesn't matter which leg I label A or B. Those are kind of interchangeable. However, hypotenuse is almost always labeled C, and you'll see why in a minute. But for now, if I'm going to label this triangle, we usually label ABC, where C is the hypotenuse, and A and B are the legs. Okay, so there's just some vocabulary you can get to fill in your notes. If you need to, you can pause the video in order to complete your notes. Okay, so this is why we label our triangles A, B, and C, because long time ago, there was a man named Pythagoras. Pythagoras was a Greek, and he was working with geometry, and he noticed a pattern that happened when the sides of squares formed a right triangle. So he noticed a pattern that happened when the sides of squares made a right triangle. So you can see this picture. This is kind of what Pythagoras was working with. And he noticed that the sides, the areas of the square, let's start there. He noticed that the areas of the square, the areas of the two legs added up to the area of the hypotenuse. So what does that mean? Well, let's take a look at the yellow square right here that says the side length is 3 inches. Well, if the side length of a square is 3 inches, then what is the area of that square? So we can look over here and we can see 1, 2, 3, 4, 5, 6, 7, 8, 9. The area of the square is 9. We also have to remember that the area of a square is the side length squared, right? And so if the side length is 3, then the area would be 9 because 3 times 3 is 9. So remember, the side squared is equal to the area. Okay, so we're going to kind of fill in this chart here really quick and see if we can see what Pythagoras noticed. Well, then if I look at the other leg, right, the other leg of this triangle was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And the side length was 4. So the area is 16. You can see that it's drawn in this picture. You can see that 16 1-inch squares fit inside the green triangle. 9 1-inch squares fit inside the yellow triangle. Well, then he noticed something really, really crazy. And this happens every time the squares, the area of the squares, make a right triangle. Well, if you'll notice, inside the big square is a little square. In fact, it's a little yellow square, right? The yellow square's area was 9. Inside here, 1, 2, 3, 4, 5, 6, 7, 8, 9. There's the little square, right? But then he also noticed that there is also a big square. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. He noticed that the areas of the two little squares added up to the areas of the big square. So 9 plus 16 gives me 25. The area of the little squares added up to the area of the big squares. And what he came up with was what we call the Pythagorean theorem. So the Pythagorean theorem says that the area of A, so let's just take A. Remember, the area is equal to side length squared. So the area of the little square, let's just put the area of the little square, would be A squared, right? The side length A squared. Or we could say 3 squared. That's what gave us the 9 over here, right? So A squared. If I add that to the area of the other leg, so we label this side length B, and that side length was area of the medium-sized square would be 4 squared. That gave us the 16. So he noticed that those two areas, 9 plus 16, equal the area, let's change colors on that, equal the area, that did not change color, of the big square, of the hypotenuse squared. So the area of the big square is 25. Let's do this. 5 squared, right? So 3 squared plus 4 squared equals 5 squared. And in fact, 9 plus 16 equals 25. So the areas add up, right? The two smaller areas add up to the bigger area. Well, we can use this Pythagorean theorem in a lot of different ways because this is true for all right triangles. It doesn't matter what side length I have here. I could change these numbers, but no matter what I change those two numbers to be, the two smallers will always add up to the big if they form a right triangle. So if they can form a 90-degree angle, then the two small will add up to the area of the big. The two small areas will add up to the area of the big. And this applies in a lot of different ways. Let's just take another look here and see if we can apply this. I'm going to show you a couple of different ways that we can apply this rule. Now, you can choose to do whichever way you like. The first way that I like to do this is I like to remember that the side length squared is equal to the area. And so if I can figure out what the side length is, then I can find the area of each of these, right? So I want to know what the area of this big square is. I don't know. It's a question mark, right? I also want to know what is this side length right here. What is that side length on my triangle? I'm going to change colors here. I'm going to make this be pink. What is that side length right there? I don't know. So I'm going to find the area and the side length. Okay, how do I do that? Well, I know that this side length right here is 6, right? So let's just label this. The first thing that we need to do is we need to label our triangle. And remember I said we always label the hypotenuse C. And it doesn't matter which leg I label A or B. They're kind of interchangeable. So I'm just going to label my short sides with A and B. And I know they're my short sides because my short sides always form the right angle. C is always my diagonal side. Okay, so first I'm going to label. Then I need to take a look at each of these side lengths. The side length of A is 8. The side length of B is 6. What I know is that this area plus this area will equal this area. Okay, so first I have to find the area of this triangle. Well, 8 squared, or 8 times 8, is 64. Now I need to find the area of this square. 6 times 6 is 36. So I know that this area plus that area is equal to that area. So I can add these two together. 64 plus 36 gives me 100. And so now I know the area of this big square is 100. Now wait a minute. What do I know about the area of a square? How do I find the side length of the area of a square? Well, if you're remembering back to homework assignment 9B, we learned that if I take the square root of the area, I can figure out the side length. In fact, we have a chart in our notes where we have all of the side lengths and areas labeled. So we could even look in our notes, and if we have a perfect square, we'll be able to use our notes to help us figure out what the root is. But if I take the square root of 100, I will be able to figure out the side length. So I've been able to figure out not only the area of the square, but I will also be able to figure out what the side length of the square is, the side length of the right triangle, the hypotenuse of the right triangle. So let's take the square root of 100. The first thing that we're going to do is we're going to either look in our factorization chart or we're going to factor out 100. So 100 is 10 times 10. That makes 2 times 2 times 5 times 5. 10 times 10 is 100. And so when I factor this out, I'm going to pull out a 2 times 5, and I'm going to end up with a 10. The side length here is 10 because 2 times 5 is 10. So I can factor out 100 and I can come up with the square root of 100, which is 10. And now I know not only is the area of this 100, but the side length of my right triangle here is 10, so I can come up with the side length of a right triangle. Okay, well, let's think of another way that we could do this same thing. Let's kind of start back at the beginning. Okay, let's say I did not know what the side length of this right triangle is, and I need to figure out what the side length of that right triangle is. The other way I can do it is I can actually use the Pythagorean theorem, and I can substitute in side A and B, and it will help me find side C. So first thing I want to do is I want to substitute in, instead of A, I'm going to put in an 8. Instead of a B, I'm going to substitute in a 6, and that's going to tell me what C squared is. So 8 squared is 64, plus 6 squared is 36, and you're welcome to use your calculator to help you calculate out what your exponents are if you need that. That gives me 100. So C squared is 100. There's my area. C squared, that's my area of my square. Well, I don't want the area. I want to know what is the side length here. What's the hypotenuse? And so all I have to do now is I know C squared is equal to 100. Well, we just solved a whole bunch of equations just like this on our homework last time when we did 9C. If I want to cancel out an exponent of 2, I can take the square root. But if I take the square root on one side, I have to take the square root on the other side. These are going to cancel out. And so C is equal to the square root of 100, which is 10. And so now I know not just the area of that square, I also know what that side length is. And so I can just use my Pythagorean theorem to come up with my area and my side length. And there's my two things, and it just depends on what I'm looking for. If I want the area, if that's my I'm looking for, then I've got it. If I want the side length, then I know how to get the side length. Okay, so here's like some examples, what you might see on your homework assignment today. It says, find the missing sides. Well, we have to remember a couple of things, and you can do it either way. I'm going to do a couple of different ways and show you. We have to remember Pythagorean theorem. A squared plus B squared equals C squared. And so on this first one, you're welcome to draw a picture, or you're welcome to use your Pythagorean theorem. I'm going to use the Pythagorean theorem on this one to find out what C is. So A squared, let me just move this thing around here real quick. I should have written that underneath, but okay. So A is 8. So I'm going to substitute an 8 in here for A. And B is 15. So I'm going to substitute a 15 in here for B. And that's going to equal C squared. Okay, so A squared plus B squared equals C squared. So I'm going to square this. I'm going to square that. A squared is 64. And B squared is 15 squared. I can't remember what that is. 225, I think. I'm going to just check real quick on my calculator. 15 squared. Yep, 225. And so I want to add those together. That equals C squared, right? So 64 plus 225 is equal to 289. That equals C squared. So now I know C squared is 289, but does this ask me for C squared? No, this asks me for plain C. So I want to take the square root of both sides because I want to cancel out this exponent of 2. So I'm going to square root both sides, and then this is going to cancel with the square root and leave me with just C. And the square root of 289, I can put it in my calculator. I can use my perfect squares chart to figure this one out, is 17. So C is equal to 17. And now I know the side length. So what happened here, if I draw a right triangle, I found out that one of these sides was 8, one of these sides was 15, and then the long side was 17. So if I drew a little picture of it, that's kind of what was happening there. Okay, well, let's try it just a little bit different way. I'll show you another way you can do the same thing. The other way that you could possibly do it is, I like to maybe draw this little chart that's up here, right? And just fill in the chart, and then I've got everything that I need. So the other way we can do this is to draw ourselves a little chart with the side length and the area, and A, B, C. I'm going to fill in my chart with side lengths and areas. And so I look at my right triangle, and remember my short sides are A and B, and it doesn't matter. I can label either of my short sides A and B. They can be switched up. But my long diagonal side is always going to be C. So I'm going to add up my areas of A and B. So side A was 7. So the area is side length squared, which is 49. B is 10. So this is 100. And then I got to find this. But I know if I add up my two areas, I'm going to get my C. So I'm going to add 149. And that gives me my area of what would be the square. But I don't want the square. I want to know what this side length is. I want plain C. So the last thing I can do is take the square root of 149, and that will give me a side length. So I'm going to try it in my calculator, 149, and it gives me an irrational number. So instead, what I'm going to have to do is I'm going to have to factor 149. So the factors of 149, what I want you to do is make sure and look at your cheat sheet. Okay, I hope you looked at your cheat sheet and found the factors of 149. The factors of 149, it says prime. Oh, okay. Well, 149 can't be factored. So I'm just going to say C is equal to the square root of 149. 149 is what we call prime. And so the only factors that it has are 1 and itself. And so it cannot be square rooted evenly. So we just leave it as the square root of 149. It's an irrational number. Okay, so now I know the side length is equal to the square root of 149. What that means in the real world is that it's a little over 12 feet long. It's 12.207, right? So this side length would be 12.02, no, 20. 12.2, and if we were talking about feet or centimeters or whatever, then its exact side length is equal to the square root of 49, which is an irrational number. It's a decimal number like pi that goes on forever and ever, but it's approximately equal to about 12.2 centimeters or inches or feet or whatever we would be talking about. So what we're looking for today's homework is our exact answers. This would be an okay answer, but we're going to work with exact answers for right now because we want to be able to later on maybe convert some of these back to areas. So we're going to leave them as exact side lengths when we find out what they are. Okay. So now, what if I don't have A and B? What if I have like A and C or B and C, right? Remember my two side lengths that make up my right triangle are A and B. And it doesn't matter which one I label A or B, but the long diagonal is always labeled C. So if I have A, in this case, let's change these because this one's B and C over here. So let's change this and make that be A and this one be B. Oh, I think I really screwed up here. That was 5. I couldn't remember what number that was. Okay, so let's make that be A and this be B. And what if I have a missing side, right, that's not C? Well, let's take a look and see what happens. Let's use our formula on this one this time, and then we'll use our chart on the other one. And I'll just kind of show you how both of these things work. A squared plus B squared equals C squared. This time, I know what A is, so I can substitute A in for A. 5 squared. Now, if you don't love the parentheses, you don't have to put the parentheses in there. I just put the parentheses in there to show that I've substituted something in for A. But we could also just write it as 5 squared, right? Plus B squared equals 13 squared. And I'm just substituting the side length in for the letter because I know what that side length is. Okay, so when I substitute in, now I just have to solve to find out what B squared is. And this is just like any other equation, right? So 5 squared would be 25 plus B squared is equal to 169. If I want to know what B squared is, I have to get B squared alone. And so I'm going to subtract 25 from both sides. When I subtract 25 from this side, it cancels. And so B squared is equal to 169 minus 25. That gives me 144. Now I can take the square root of both sides, and B is equal to 12. I know now that the side length of that right triangle is 12. So I can use my Pythagorean theorem and just substitute in the values that I know and solve the equation to find the missing side length. Or I can write my chart out. Here's my side lengths. Here's my area. I need an A, I need a B, I need a C. These two areas are going to add up to my third area over here. Well, let's figure out what we've got. I do not know what A is. I have nothing for A, but I do know that the side length of B is 14. So 14 squared is equal to 196. And I do know that C side length is 22, and so I can find the side length 22 squared is 484. I know that this plus 196 has got to be equal to 484. So if I wanted to find the area of A, or what we would say is A squared, right? Then all I have to do is take 484 and minus the 196 from it. That gives me 288. I'm just going to check my work with the calculator here really quick to make sure I'm not leading you astray. 288, I did that right. Okay, and so then I know that side length A, or A squared, is 288. So I can take the square root of 288, and I can figure out the side length of A. 288 does not square root evenly. So I'm going to look up my factors on my factorization chart. It only goes up to 250. So what I'm going to do instead is I'm going to take 288 and divide it by 2 just to reduce it down. I'm going to count the 2 as one of my factors because I divided by 2. And then the other factors, half of 288 would be 144. So now I can look up 144 on my prime factorization chart. And I can find out what the factors of 144 are. And I get 1, 2, 3, 4 twos, 1, 2, 3, 4 twos, and 2 threes. And I like to break mine up into group of twos because then I can see what I've got here. Let me kind of move this up so I give myself a little bit more room. I'm going to pull a 2 out of there, another 2, and a 3. So 2 times 2 times 3 would be 12 with a remainder of 2. Here's my remainder, right? So this side length would be 12, remainder 2. All right, what's the tricky part? Well, we just got a side length that was 12 remainder 2, right? So what if my side length is 12 remainder 2, or I'm going to use this example, 2 square root of 5. This is just another one that's similar to our side length before, right? If my side length before has a remainder on it, like what we got just barely, how do I get the area? How do I square that? If I need to find, let's say my side length was 12 remainder 2, or let's do 2 square root of 5 first, because that's our example we have here, and then we'll see how we get back to our area. If I find out I have a side length, and I need to find the area, well, that would mean I'd have to square this. So how do I do that? Well, when I square a side length that has a remainder on it, what I really am doing is I'm squaring each of these things individually. Remember, when I have an exponent on the outside, I kind of distribute it to everything inside the parentheses. And so what's happening here is I really have 2 squared times the square root of 5 squared. So I'm going to kind of do these two things separately. 2 squared would be 4 times, well, when I square a square root, remember, those cancel each other out. And so 4 times 5 would be equal to 20. So my area would be 20. How do I square this? Well, I square each of these parts individually. First, I square the front number. Then I square the square root. Then I multiply them together. So pause the video and see if you can square 12 square root of 2 and see if you can get back to 288. Remember, 288 was the area on that. Let's see if we can get back to that. So pause the video, try this on your own, see how you do. Okay, hopefully you tried that on your own. And what we're going to do, remember, is we're going to square each of these individually. So I'm going to get 12 squared, and I'm going to times that by the square root of 2 squared. So 12 squared would give me 144, and I can use my chart to look up the perfect square for 12, or I can calculate it in my calculator. And then remember, the squared and the square root cancel, so I'm going to get 144 times 2, which gives me the 288 that I was looking for. So we can go either way with these. All right, so what if I get something like this? Well, any right triangle, it doesn't matter what my side lengths are, but if I have a right triangle, if these side lengths are side lengths of a right triangle, and so the question is, do these side lengths make a right triangle? Well, if these side lengths make a right triangle, then the Pythagorean theorem has to be true. A squared plus b squared has to equal c squared. Otherwise, it is not a right triangle. The Pythagorean theorem is true for every right triangle. So all I need to do is figure out which one of these side lengths is my biggest side length. And the quickest way to figure out which one of these is the biggest side length is to square all of them. So the first thing I'm going to do is go in and I'm going to square all of these side lengths. And when I do that, that's going to tell me my biggest side length. So first I'm going to go in, I'm going to square all of my side lengths. The square root of 5 squared, well, remember, this and this cancels. So the area of the square root of 5 would be 5. This and this cancels. So the area would be 20. And then finally, 5 squared would be 25. So now I know these are my two shorter sides here, right? So let's just fill these in. The square root of 5 and the square root of 20 are my A and B sides, and 5 would be my C side. So now all I have to figure out is, does A squared plus B squared equals C squared? So let's put it in here. A squared was 5, B squared was 20. Does 5 plus 20 equal 25? Yes, it does. So this one is yes. It is a right triangle. So on your homework assignment, you're going to first find your two shortest side lengths, square them, and then make sure they come up to. Now the other way that I could do this is I could turn these two into a decimal. I could square root 5 in my calculator, turn it into a decimal. I could square root 20 in my calculator, turn it into a decimal, and find out if these were bigger or smaller than the 5 side, right? So the other way I could do this is first turn them into decimals and find my two shortest sides. But I always have to make sure that my two shortest sides add up to my longest side. And I have to make sure that I'm adding the two short sides together. The two short areas or the two small areas together. That's what I'm looking for. Okay, so here's an example. Are these right triangles? Let's find out. The easiest way to find out my two shortest side lengths is just square all of my numbers to start with. So I'm going to square, 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 right? So 3 squared is 9, 2 squared is 4, and the square root of 5 is 5. So now I want to find my two shortest sides. 4 and 5 are my two smallest areas, and I want to see if they add up to my biggest area. And so they're not going to necessarily be in order, right? These two smaller ones were on the end this time, and this was my biggest. And so I wanted to make sure that my two smallest areas add up to the big. And since that is true, this one is yes. It is a right triangle. Okay. What about this last one? Well, the first thing I'm going to do is square everything, right? 11 squared would be 121. This is going to cancel that square root, and I'm just going to be left with 51. And then 13 squared is 169. I want to find my two smallest areas. Add them together. 21 plus 51. Does that equal 169? If it does, then I have a right triangle. So 121 plus 51 gives me 172. Does that equal 169? No. So this one is not a right triangle. Okay, so there we go. All right, what I'd like you to do is pause the video, try and work out these last couple of problems before you start on your homework assignment. See how you do. See if you can get the right answer. If not, make sure you go back and review. Maybe you missed something. Or you're welcome to email me or Mrs. Zeider and let us know if you need a little bit of help. Okay, so pause the video, try these on your own, see how you do, and then come back and check your work. All right, I'm going to show you these last couple of problems so you can check your answers and see how you did. The two short sides I'm going to label A and B. And then the long side, remember the hypotenuse side is C. And so A squared plus B squared is going to equal C squared. And I'm just going to substitute in some of the side lengths here. A would be 11 squared plus 20 squared, and that's going to equal C squared. So 11 squared is 121, and 121, and 20 squared is 400. And 121 plus 400 gives me 521. That equals C squared. Well, I don't want C squared. I just want the side length. I want C. So the last thing I have to do is take the square root of both sides. And that gives me an irrational number in my calculator. So I have to split it in half, 521. Ooh, that's not going to split in half. It is an odd number. Let's see if 521 is prime. I usually check a couple of different answers 521, I check and see if it divides by 13. I check and see if it divides by 7. I check and see if it divides by 3. And none of those work, so I'm just going to leave it as C equals the square root of 521. If it doesn't go into any of those, it might be a 17. Nope, even 17 doesn't work. So we're just going to leave it as the square root of 521. There's my side length. If you guys get an odd numbered side length like this, and it's hard to factor out, then I usually, my kind of general rule is try dividing it by 3, try dividing it by 7, and try dividing it by 13. Try those, like some of the basics. You can also try 11 and 17. Those are some weird odd numbers that have, but if those don't divide out evenly, if you can't factor it that way, then just leave it. So the side length is going to be the square root of 521. Okay. Last one, let's do this one. And so if I do a chart on this, I'll do side lengths and areas. Side length of A would be 3, and so the area is 9. B, I don't know. C is 5, so 25. 25 divided by 9. 25 minus 9 is 16. And so the square root of 16 is equal to 4. So my side length on this one is 4. I'm glad that one came out nice and even. Okay, so now I know all of my side lengths and all of my areas, and I'm ready to go. Okay, if you have any questions, make sure you're talking to me or Mrs. Zeider and letting us know if you need any help. Okay, thanks, guys.